Hi, I'm Jack Velicky, representing Team 7 Cooling Systems in their DP3 presentation. To review the most fundamental aspects of our last two presentations, we should talk about the mission statement to begin with. What our mission statement boils down to is that we are developing a small device that will regulate most any fan speed to maintain a specified temperature. We are mainly targeting college students that do not have AC in their rooms. Our secondary targets are people that use fans to influence the temperature of a room. The customer needs that we found most important were ease of use when setting up and changing the temperature, as little maintenance as possible, keeping the fan as powerful as possible, and containing a simple fan on setting. From these customer needs, our specifications were made. Our specifications were used in a QFD chart to determine the technical priority of each specification stemming from the customer needs. The functional decomposition discussed in our last presentation lays out different desired actions that we want our device to complete. Next, we used the 4-2-3 method to generate different ways that the device could theoretically regulate the room temperature. And finally, we chose the electronic regulator powered by a battery with an input given to the Arduino through a cord with one's computer. And this decision was made using concept screening and concept scoring. Having conducted research on the idea of fan temperature control, we have concluded that our fan regulator is fundamentally a new product that has not been produced to market, and that one that doesn't contain any fundamentally new technology. From our research, we have seen that all fans controlled by their environment's temperature do exist, but these fans are expensive and are sold altogether. Our device is different in the way that you use it with your fan that you already own that doesn't have environmental control, and you just apply it as a device. All the technology used in the making of this device has been available for public use for quite some time, and any patents that were placed on the technology has been removed. The most similar patent to our design is a patent for another fan-controlled device method. The sensor does not require any manual manipulation to turn on the fan. It connects to an Arduino to a motor driving module, which is connected to the power source. The motor and the controller are electronically connected. The limitations that this patent has on the team's current design is that it is similar, so depending on what components and methods that the patent creators used when submitting their patent, the team may or may not be able to submit this and get it officially patented. Next, we have the FMEA. Failure mode effect analysis suggests that our device has a good chance of keeping the customer satisfied. We came to this conclusion based on the account of the relatively low risk priority numbers for each function that the device contained. Also, when the risk priority numbers were averaged, we found that the device altogether has an RPN of about 13. For the design manufacturer, we first considered the tasks required during the manufacturing process. These tasks included, in order, orienting the wires into the cells of the Arduino. The team determined that handling each wire was predicted to take about 5.85 seconds, while the manual insertion time per part was calculated to take around 6.5 seconds. In total, this step would be the longest part assembly time within the assembly of the entire device. The next task would be to include plugging the USB, which connects the Arduino to the laptop, which the manual handling time per part was calculated to be 2.51 seconds, while the manual insertion time per part was also calculated to be 2.51 seconds. The third task is a simple click of a button, which is meant to send the pre-written code into the Arduino. Since this step could not be measured against the chart and realistically took less than a second to complete, we use the 10 seconds that the computer actually takes to upload the code to the Arduino to determine the total part assembly for this part. For the final step, the team calculated that the time it would take to handle the USB as it is unplugged from the laptop would be a total of 2.5 seconds. As a result, we concluded that the total predicted assembly time would be around 5 minutes, and the predicted assembly cost would be $1.31, as the person employed would be have a wage of $15 per hour. Now for our CAD model is crucial to our device, as it presents a way for the customer to visualize what we are promoting, and it's a quite simple design, that it only contains a fan connected to the Arduino with a temperature sensor located at the top of the top of the fan. And this model is also a good visual for the customer, showing that our device is not invasive on their room at all, and it isn't aesthetically unappealing. Now, as you can see here in our bill of materials, most expensive part is the Arduino circuit starter kit, which was $27.99. This made up nearly half the cost of the entire fan regulator. When thinking about production on a large scale, many of the components above would have cost less if they were bought in bulk. For example, a pack of 5 thermometers only costs $7.86 compared to the one costing $9.94. Another way that the cost of materials could have been mitigated would be through saving money on shipping costs if certain components of the device weren't ordered using express shipping. Now, for our final prototype, our final design phases of testing, were able to successfully use the data from our thermometer to change when a servo motor would be spinning. We were unable to integrate these capabilities to change the speed of a fan. However, we have ideas on how the progress could be taken further into control of the speed of the fan. A full list of items for our product contains an Arduino, a breadboard, some wires of different lengths, a capacitor, a transistor, a servo motor, and a thermometer. For our reflection on our product improvements, we concluded that even though we were unable to change the speed of a fan using our prototype, this was due to lack of time to develop the proper hardware, specifically a way to connect the motor on the dial of the back of the fan to change the speed. Ideally, there would have been a range of fixtures that could connect to a number of different popular fan models. There should also be a casing around the Arduino that exposes the USB Type B port if the customer wants to change the minimum temperature of the Arduino code. There should also be a sleeve that guides the motor's wires and thermometer wired together towards the fan, where they will separate and be mounted at various points on the fan. Thank you for this time, and that's it.